My name is John. I'm working as a product manager with MEWP. I have about 20 years experience in the industry and a lot of work on doing pressure vessels with ASME U-stamp designs. Please feel free to message in the chat area. I'll be able to see your messages and give any clarifications or any explanations as required. I hope you're able to hear me well. So, in this times of COVID and the lockdown, when everyone's stuck at home or forced to work remotely, we are offering a solution where we hope that people will be able to use effectively. It's a cloud-based software for pressure vessel design. Using the software, you can design horizontal and vertical pressure vessels. Intuitive wizards, which pop up on the screen, make it easy to enter details and select the options. And you can see the whole vessel being designed in 3D, and it makes it easy to understand and easy to implement. Right from the design, you get the ASME design report. And you can also generate a complete 2D drawing from the vessel which has been designed in 3D. How does this all happen? We have a powerful user interface to help us, and it's an end-to-end solution right from design to the drawing. And our vision is that you'll be able to achieve faster time to market with a tool like this. One of the advantages of being a cloud-based software is that different people can work from any location and access the same data. The same data can be used right from the proposal department to the design engineering and the detailing, and even can be viewed by the people on the shop floor. So in this time of remote working, our vision is to provide a tool which will help engineers succeed. We'll switch to a demo of the software, and I'll walk you through the software and you can understand how it's done. I hope you can see the screen of my application. This is the general geometry design screen. So this to give you an idea of how we do it in 3D. Now what I'll do is I'll log out of the application and log in again. So it will be easy for you to understand how to get started with the application. The main application screen can be accessed through a browser window. The entire software runs through the browser, and you don't have to install any software on your PC, on your hard disk. The application is accessed through a browser page. What I'll do is I'll show you the entire browser screen, so you'll be able to understand how the So you can see that I'm using a Chrome browser, and here on the top is the app link. So you have to enter the app link, app.mewp.ai in the search bar, and press enter, and it loads up the login screen. So on the login screen, I'm going to enter my username and password and click on the login button. The moment I get into the software, I get onto the dashboard. The dashboard is an easy way to see all the projects which I've done, and all of them are listed in this dashboard with the project name, the type of vessel, some details on the client and some specifics on the project. Now we've given an easy way to shortlist the projects. So there are some areas where we can enter a short string, and the software will filter the particular string on which we've entered it. For example, if I want to look at only the deaerators, I just enter the first letters of that vessel type, and all my deaerator vessels have been shortlisted. In addition, I can shortlist further on a particular client or project and reduce the number of options to drill down on a specific vessel. So I can clear that, and we can also start with a purely fresh project by clicking on the Start New Project button. So I'll take that option, and I'm starting a completely fresh project. The first screen that I get is the one to enter all the project inputs. So let's say I'm designing an air receiver, and the duty would be water and air services. Let's just enter some file data, and I'll go with a location Pune, and a project is expansion. And here also I'll just put some dummy data but you can enter the specific data of the particular project. Right now we are handling in SI units. So I click submit, and it enters the project information, and now we get to the screen for the design data. So here I'm entering the values in MPa. I can have a quick converter where I can see that I'm entering the data. So here I want to use a, let's say, a 10 bar design. So I go for 1 MPa. Yes, I can quickly see that it's around 10.19 kg per cm square. Design temperature, let's say 50. I'm just using an external design pressure, although an air receiver would not generally be designed for vacuum as well. You have an external design temperature of 25. I give a corrosion allowance of 3 mm, and the fluid inside I say is going to be air, gas, and the density would be 1 kg per meter cube. Test fluid would be water, and the design code ASME. And I select, okay, let me go for spot radiography for both longitudinal and circumferential joints. And then I go to the next screen. Here I can enter the wind load and seismic inputs. I'll accept the defaults, and we go for live load. I'll accept the defaults again, and I won't include any static head. There is no insulation, and these are the typical load combinations which are calculated in the software. And I go on to creating the 3D design. So now I am using my 3D design input screen. It's a fresh project, so it's absolutely blank. The first step is to start with a shell. So I can use these icons on the left menu bar to select the particular type of component I want to start with. So in this case, I'll start with a cylindrical shell. So when I click on this icon, I get a wizard. It's a shell wizard, which enables me to design the component. And it gives me a dummy shape to indicate what it would look like. So I can either go for a horizontal or a vertical vessel, and the dummy would update to give me a real-time feedback as to what it would look like. So I'm having an inner diameter of 1.5 meters, and it's going to be made out of a plate, 1.5 meters high as well. So let's increase that. Let's say I want a shell of 2.3 meters high, and it updates. So then I go to my section where I select my material. So it's very easy to switch from tab to tab, and and in case you want to see all of the options at the same time, there's an option here which enables you to see all the screens at the same time. And in case you want to do a lot of quick input here. So I'll move back to my single screen. So this presents the data sequentially. So it's easy to go step by step And once you're a little more familiar with the software, it becomes faster perhaps to see the entire screen and pick up, enter all the data in the widescreen. So now I'm going to tab 3, which is for materials. So by default, the material selected is SA516 grade 70. Other materials can be selected. So here we have a list of all the ASME plate materials which are available from section 2D. If I want to select a specific grade or some short string, I could, if I use a search option, let's say I wanted to select something out of the 3 or 4 materials. So I press enter that string, press this, click the search button. So the software would shortlist materials. And if I were to look now into my drop-down list, in addition to the existing material, all the materials in which 3 or 4 would be available would be shortlisted. So I could switch my material grade to 304. Again, let's try what 516 grades are available. So I click search again, and I have all the grades from grade 55 to grade 70. So I'm selecting grade 70. The notes which are applicable to this particular grade are shown in the notes box. And then I can also use the next button to go to the next tab. And this is the tab which gives me the design calculation of the quick design calculation. So for my vessel, the 10 millimeters would be the minimum thickness required, and that's been calculated because the calculate value is 9.4 millimeters. So once I've got to this stage, I can click finish, and my shell is there ready on the screen. Now, if I wanted to change some parameters, I could click the shell again. It's very intuitive. So it shows you move over the object, it changes its color and enables you to understand which object you can select. So I can edit the same object and I get the same screen back again. So I can go back, and in case I wanted to change the thickness, I could select a higher thickness. Let's say I have plate material of 12 millimeters available, so I select 12 millimeters. Then I say finish, and there's my shell again with 12 millimeters. There's some other utilities available as well in the wizard. I go back to edit, and here I can see a quick bill of material of the particular part being designed. So here, there's my plate material, 516 grade 70, and the length would be 4.75 and with a width of 2.3 meters. That's the height, and the developed length is calculated and including the weight. So it's a very quick way to quickly see what the material input is going to be like. In addition, I can also see a quick report of the design of the particular component. So this is a sort of a summary only of the section which is being designed. So you have all your basic data, you have the results in terms of the minimum calculated requirement, as well as the provided thickness, and all the individual sections of ASME like circumferential stress, longitudinal stress, and the UG16 requirements are also provided. So I close it, and then I finish my design. So there we have all the options available for shell design. In addition, we have also the option of selecting pipe material for your shells. So you can go to the second material specification screen, and instead of a plate, I could pick up a standard pipe. So it provides all the B16.5 pipes are available for selection, and I could select any one of them, and it gives me the inch as well as the millimeter designation. So it's very easy to select some similar pipe size. Let's say I wanted to go with a 40-inch diameter shell made from 40-inch. Yeah. So now you can see one other feature is that when we are editing a shape, it shows the original shape as well as the dimension which it is going to change to. So it's a little help to understand that I'm choosing a diameter which is less than the one which I had earlier selected. So in case I don't want to edit, I can just quit and I just keep my original dimensions. So now I go for an option for selecting the dish end. So I'll select a dish end. I get a similar wizard, and we can go for the options either a hemispherical end, spherical end, or an ellipsoidal end. Here, let me choose ellipsoidal, and we go ahead. I'm going to place it on the top of the shell, so the top option is selected. And then we go with a straight face, 25 millimeters, 2:1 ellipsoidal. And next, we can specify a specific thinning allowance. By default, it's 15. The same SA516 material is there by default, and it will calculate the required minimum thicknesses and suggest thickness of the ellipsoidal end. Again, I do finished, and here we have our dish end at the top. So I'll quickly put in a dish end at the bottom as well. So the same way, ellipsoidal, right? This is going to be at the bottom, same details and same material, and it's selecting and finish. So there I have the body done, shell and two dish ends, and I'll just save my vessel at the moment. So now I have various tools to quickly go to various views of the object. So, and then I can scroll in, I can pan on the object and easily see from all angles. Next, I'll pick up a nozzle. So let's say I want inlet nozzle. So I can specify the service. So this will later come on my nozzle schedule. So I go for an inlet nozzle, and it will be made out of a standard pipe, and it will be on the shell. It's a radial type of nozzle which will be set on. And okay, so here we see it's about halfway up the shell. The position is 270, which would be towards the front, pointing towards the front. And either it can automatically calculate the projection using the standard length of the nozzle, and the pipe is SA 106 grade B, and here I have a chance to select the, let's say I want a 5-inch nozzle, and the diameter of the pipe comes automatically, and I can select my length required, let's say 200 millimeters, and yeah, it does the calculations. So it says that yep, this schedule is unsafe, so I go for a higher schedule, and then I say next, and then I could choose whether I would have a pad plate or not. In this case, let's say I'll go for a pad plate. So the pad plate dummy is shown to see what it looks like. The well detail of the pad plate is chosen, and I go for next. I can select the material of the pad plate, give the thickness, the well details, and it does the calculations of the reinforcement, and I say finish. So here I have my nozzle with the pad plate and on the nozzle. Now I'll put a flange onto the nozzle. So I go for flanges. This is the icon for flanges, and it's a standard flange. Now I select the type. Let's say we want slip-on flange, and it'll, and so I'm picking the inlet nozzle on which I want to put the flange. It's a forging 105 material, and it'll be of 150 class, and it automatically does the checking for the pressure temperature rating, and it automatically gives you the projection from the center of the vessel. So I say finish, and there I have my flange on my nozzle. Again, I save. Yeah. So I'll quickly show you now how the report is generated. So here we have all the utility buttons. So various things like the design data can be immediately viewed just for a quick check. All the original data is presented. This will be coming onto the drawing. And we can also see the nozzle schedule. So the details that we enter, the inlet nozzle is the service, one nozzle, the diameter of pipe, thickness, and other details will come on the nozzle schedule. This again will come on the 2D drawing when we generate it. In addition, you can see the a quick thing of the bill of material so far. This is all the components which has been used in the bill of material so far. And then I click on design report, and the software will run in the background and generate the design calculations. So the calculations are being run on the server where all the data and the calculations are provided. And here we have our design report. So we have a title page, the basic project inputs, basic inputs in terms of the design pressures, corrosion allowances, selected design standards, the well joint efficiency selected, site details. These are all there in the beginning. Then we have volume and weight calculations. Then additional weight calculations, including the weight summary, are provided. Then static head calculations, if required. Then it does the external pressure calculations, and then each individual component, the design calculations will be done. We have the basic input data, and then uh, clause by clause, longitudinal and circumferential stresses, minimum shell thickness is calculated based on the governing thickness, and then it does checks including fiber elongation and maximum stress for hydro. Similarly, for the ellipsoidal heads, the calculation would be done. Then we have calculation for the nozzle design data, and the clauses for the nozzle, as well as the reinforcement calculations. So this design report is available, and we'll close that. Now we go to the other feature, which would be the drawing. So here we have a button for downloading of the DXF. So I click that and I get a, okay. Now one of the options is to go for a full screen mode. So when you go for a full screen mode, you get more screen area. So this can be activated at any time using an F11 button. So this is one of the browser features. So I'm just using that to get more space for my menu. So we have quite a few options for the drawing. You can see that right now these are the defaults which have been selected. We go for, it's a third angle projection. Sheet size is A1 size. We're going to have front view, left view, and top view in the drawing, and it'll be in landscape mode. We can enter details in the title block. So receiver, and you can enter and you can all give all details, including details like who's drawn, checked, and approved by, and even revisions details can be entered. These are not controlled, but they can be entered, so it goes onto the drawing. So this would be the first release, and created by, let's say, myself. Okay, and I save these details. Various details will also be printed on the drawing. So checking the box will either put it onto the page 1 or put it on page 2, which would be the page on which the details are available. Specific notes can be entered into the drawing. Okay, so I say test notes. Okay, so I have all. Okay, I will save these details, and I can add notes as well. So I have notes 1, and I have my second notes. Okay, so I say notes line 2. Okay, okay. Um, and yeah, so the initial design data which is there on the project is brought up automatically. Then and you can edit it if required at this final stage before it goes to the final drawing. And bill of material is also provided. Any last minute edits can be done here. Similarly, nozzle schedule is also okay. Let's say I want to add a width meeting flange. Okay. And similarly, there's an MOC table which also can be provided on the drawing. So these are the materials which have been used so far in the drawing: the shells, heads, nozzle pipes, and flanges. Okay. So then I'll click on create drawing. So now the software will go into the backend, and as we have entered each and every detail of the parts, the shell, ellipsoidal ends, and the flange, all these details are used to actually create the 2D drawing. The 2D drawing gets downloaded onto the hard disk, and this can be opened and viewed. It will be in DXF format. Yeah. Now I'll just open my 2D editor to show you how it looks like. But just before that, as we're coming to the close, I'll take any questions, and I'll open the thing in the background. Okay, so this is the drawing which we had prepared automatically through the software. I had downloaded it onto my hard disk, and I'm using the Solid Edge to draft to open it. So these were the components that we had designed. We had a shell and two dish tents, a nozzle and flange. So automatically there's a title block. The notes which we had entered are come automatically, and they can be edited. And here's the design data section and the nozzle schedule. And there's also the individual details are prepared on the detail sheet. And here on the right side would be the bill of material, which is again automatically prepared on the drawing. Okay. Now, Shantanu asked a question: can we import any 3D diagram directly? No, we don't have that feature at the moment. You have to design the components inside the software itself, and but we believe that it's so easy to design the components. There are other features which are also quite useful. You can clone models. Um, so I'll just go back to our app window. So if we go to our main dashboard, uh, okay, hope you're able to see it. Now, let's say this is the air receiver which we had just made. So now let's say I want to create a version of it, or I want to make a slightly different version of it. There's a clone button. So it's just like copying it. So I clone the air receiver. The software will clone the entire vessel and prepare a copy of it. It adds the date timestamp along with the file, and you get a totally new version of the vessel. And it's easy to edit the new version and make alternate designs for different pressures or dimensions or capacities. So, yeah. Yeah. Uh, Right. So this is the copy of the air receiver which has been made. So that can be opened, and you can you'll get all the exactly the same designs, details, and this can be edited. For example, now the software has option to quickly edit this things. Let's say I want to increase my diameter to inside radius is now 900. Diameter will go up to 1800. And one of the advantages in this is that automatically the components which are along with the main shell also get automatically updated. So along with the shell, my distance have already been increased in size because they are related to the shell. So we think that when doing the designs inside the software, it will automatically permit very fast design, and that's one of the reasons we prefer to edit inside the software itself. There's another question option for supports and manhole doors. Right now, we are not given a manhole option. We have You can design a large diameter nozzle and put a flange and a blind flange on it. Uh, as and when we get requests from clients, we take it on priority. There are a large number of clients requiring the same option. It's just that for manholes and things like that, there are so many options for design that we haven't selected any specific. Yes, saddles can be designed. So I'll just show you one of the, right now this is being a vertical vessel. I'll show you the legs. Saddles also available for horizontal vessels. So for vertical vessel, we can put legs. So let's say that I go for channel and I'll select, let's say ISMC 150. Okay. And I'll just select the default options, and it does the basic calculations, and you can see that the legs have been put into the drawing, into the design. Yeah. Yes, saddle is available, but being a vertical vessel, I can't select saddle right now. But this saddle option is available, and on a horizontal vessel you can select the saddle and click, and you'll get a saddle designed into the vessel. Yeah, Rajvardhan, I hope I've yeah. Fluid type steam. Yeah. So right now we just have a very rudimentary entry for the type of fluid. So there is steam is available, and we have skirts as well. But also skirts is very simple type of skirt. Skirt is also available. Yeah, in one of the options. Can we get load data and foundation bolt sizes? Yeah. Yeah, right now the tube sheets we are preparing. There is an option for tube sheets. I'll just give you a very demonstration. It's under preparation, and it's a beta feature right now. So what I'll do is I'll just delete this. It's very easy to completely delete all the components in a vessel. So I'll just select. Okay. Okay, what happened there? Okay, so okay, let's see, saving. Okay, so we do have the tube sheet option. So when I select tube sheet, there are a lot of okay, and let's take the defaults, and yeah. So yeah, you. So right now we have a fully tubed tube sheet with a flange type, and yeah, right now it's under beta feature, and but it is there right now. Yeah. So right now we see the big advantage in being able to generate your 2D drawing extremely fast, and the bill of material and as it will be available right from the design, and the 2D drawing can save a huge amount of work in preparation of proposals and as an input to final detailing. The advantage is also that it is a cloud-based software, so different people can work remotely and share the design, and you're not constrained that you have to go to the office. Doesn't need any specific software to be loaded onto the PC. It's worked through the cloud, and we have the Okay, yeah, you can save any number of projects. So in the dashboard, uh, there's no number of there's no limitation, so you can save any number of projects, and it's very easy to filter either based on the vessel or the project name or the client name, and you can easily filter out projects and find out and select the ones which have been used. The latest designed projects will always come on the top, so the most recently used projects will be shown right on the top. Shipping list or summary part list. Yeah, the right now the software gives a bill of material. So if you can send perhaps by email some details of what exactly you mean by shipping list or summary part list, we would be happy to handle that separately. The bill of material will be available from the software directly. Ligament. Okay. Yeah. Yeah. I think some of the questions are getting to be quite detailed. So, yeah, for as far as the development, it's just a plain standard development using the mean diameter. Uh, so, for any specific requirements, it could be added into the software if if we want a specific requirement, we'll look at it and add it. But right now, it is the finished cut length which will be rolled. The extra is not available. Foundation bolt sizes, yeah. Yeah, the questions is whether there's load data for the vessel and foundation bolt sizes. Yeah, right now we have the basic saddle design, and you can specify the bolt sizes in the saddle, but the software at the moment doesn't recommend the bolt size. But the saddle calculation will be done with the given bolt sizes. Ligament efficiency calculations are presently not there in the software. We have an idea about it, but right now it's not present. We have the options for entering the pitch and the diameter of the holes, and we can add it if you feel that it's a specific hitch for you to go ahead. Right. Yeah. So we've gone. Yes, yes. We had some couple of additional questions. If there, what is, yeah, we are planning to add the cost estimation. Yes, since we have the full details on each of the materials as well as the weight and size, it would be possible to add, and certainly it's on our time plan to add costing, and we will have two options. One is the default cost, which will be available in the system based on general rules, and you'll be having the option to enter your own specific cost details of your own, and you will get your customized cost of your specific um, company. If number of nozzles are there, then how to? Yeah, just keep adding nozzles in the drawing, in the design. So I'll just go back to my receiver. So there was one particular nozzle. So just select a nozzle again, and it will put another nozzle into the drawing. So this time, let's see, we'll go for putting the nozzle onto the dish end, onto the top dish end. Again, I have radial and angular options. So I'll just put radial nozzle, and it's set on, and I can give the offset distances. Let's say I give 300 on the length side and 200 on the other dimension, and you can see that the radial nozzle is being put in onto the dish end. So just select the additional nozzle, and it will keep putting the nozzles. Here it's a radial nozzle onto the ellipsoidal end. So just keep selecting the nozzle icon. So each time you click the nozzle icon, a fresh nozzle will be designed and added to the existing design. Yes. Yeah. In case of amendment in ASME, we will add and we will update the design as per the latest code. We will not be handling backward compatibility. That is, we will only be supporting the current ASME code at that particular point of time. So right now we don't envisage that we will give versions and you'll be able to design as per some earlier version. Whatever the latest amendments, we will update and we will add in. Now, the advantage of the cloud-based software is that when we update the software, it's done at the back end. So the next time you open the software, whatever feature is being added, whatever correction, bug fix, whatever is required, it will automatically come into the software that you are using. So there's no need to specifically design or download any particular version or update the software on desktop. It will happen at the backend automatically. Same nozzle by changing pitch is possible or not? That is, you mean to say change the position of the nozzle? I can, if that is a question, I can answer that. So let's say that this was my earlier nozzle. I can edit it, and I earlier it was at a distance of 1,150 from the bottom. I want to push it up by another 150 mm, so I put 1300. So this is the dimension from the bottom of the shell on which it is located. So it will automatically update the position and show you how it is moving. This is a benefit you can check in case of fouling onto any of the existing nozzles or stiffening ring or things like that, and then you can get an idea how much is possible in the shifting of the particular nozzle. So I go through the entire steps and finished, and it has changed the dimension, and nozzle has the flange which is attached to the nozzle has also shifted accordingly with it. In addition, if required, I can even change the size of the nozzle. Okay. Yeah. Yes. Yeah. We'll give you the pricing. You can send us a mail, and we will send you a mail regarding that. Yes. The software is done on a licensing basis, on a yearly basis. So it's very economical compared to buying a new software. So the price is comparatively much lower than any one-off price that you pay for the software. And we require to do it on a yearly basis because updates and development is happening on a continuous basis. So to keep up with that, we can do it. Yeah. Now, when we have a single license, all the reinforcement pads, the compensation calculations is there. The material provided and the limits of reinforcement is being done. Yeah. At the moment, lining is not being provided. Uh, yeah, but certainly chemical industry and breweries and are all a very important market segment for us. So we are planning for doing a lot of features specifically targeted towards process industry, and yeah, lining would be one of those. Jackets are heating jacket and trays are also on our plan to put, but at the moment it isn't there right now. Yeah. Our vision is to create a software which is really user friendly. So first we'll be going for these components as well as things like fittings, for examples, couplings, thermal wells, side glasses, various things. We require your support in terms of also if we would like to take component by component and vessel type by vessel type and finish. So we request your support in using and giving us the feedback, and we will certainly add in as soon as possible these features. Right now, for example, you can do custom flange design. You can design as per Appendix 2. That features already there in the software. Yes, lifting lugs right now is present. So standard year type lugs, the calculations are being done inside the software. Right. It's yeah. So yeah. So we'll take all these questions. You can write to us, and certainly we'll reply as soon as possible. So right now I'll be closing the session, and we'll take all of your questions. Please write to us. Our website is mawp.ai, and I'll ask Fahim is to there to support you. He will send you and help you all your questions. Right. Thank you.